The sun is dying. You're a great scientist, Dr. Grace.
Is that me?
I'm Grace.
Earth is going through some tough times. The solar energy reaching our planet has dropped drastically. The culprit? Astrophage. A microscopic organism that consumes stellar energy, including our sun. These organisms migrate between stars via infrared paths. Earth is predicted to face a total ice age in less than 30 years. Doom is imminent.
If we do nothing, everything on this planet will go extinct, including us.
To solve this existential crisis, Earth sends 3 of its best to Tau Ceti. Tau Ceti is the only star in the galaxy known to be free of astrophage. It's located 12 light-years away. That's the premise of the novel Project Hail Mary by Andy Weir, which was later adapted into a film directed by Phil Lord and Christopher Miller, starring Ryan Gosling as Grace. As of this recording, the movie hasn't been released yet. To avoid spoilers, we won't discuss the plot. Instead, we're going to audit the science. We'll look at how accurate the movie is based on the original novel. Grab your coffee. Let's dive deep.
Now or never.
The protagonist, Grace, travels to Tau Ceti in a massive ship weighing 2,100 tons. 100 tons for the ship, and 2,000 tons for fuel. Using astrophage as fuel, Grace's ship in the novel can reach a speed of 0.92 C. To get there, the ship goes through 3 phases. Acceleration to 0.92 C over 1.5 years, cruising at 0.92 C for 10.5 years, and then braking for another 1.5 years. Total travel time, 13.5 years. If you factor in the return trip plus 6 months of research with an alien friend, Earth wouldn't be saved for about 27.5 years.
I'm gonna call you Rocky.
By then, the planet would already be entering a new ice age. The author, Andy Weir, is a devout follower of general relativity. Every scientific framework in this story is grounded in it. Weir states the ship must accelerate constantly to maintain 1.5 Gs of gravity. Otherwise, Grace would arrive at Tau Ceti physically frail.
But with long-term space flight, we're not sure that'll happen. We also know that Scott got a thicker carotid artery in space, made up of collagen, that he had changes in the sclera of his eye, made up of collagen, and patients I see in blood pressure clinic who have genetic defects in collagen type 3 have a syndrome which makes it difficult for them to stand up.
And this is correct under general relativity. If the ship coasts after reaching top speed, the gravity drops to 0. Therefore, constant acceleration is a necessity. Now let's dissect this. Why didn't Andy Weir dare to break the laws of relativity? Because if he did, Earth could have been saved much faster. Let's prove it. let's look at what happens when we follow the rules versus when we break them. Get ready for a headache. Let's talk about the prohibitions. First, Lorentz symmetry. It states that the laws of physics must remain the same, or invariant, for all observers, regardless of their orientation or constant speed. The consequence? Space and time must bend. Contraction and dilation. Energy and momentum must be redefined. The speed of light, c, is locked as a universal limit from the start, rather than being discovered through long-term acceleration experiments. Then there's relativistic momentum. In classical mechanics, P equals m times v. In relativity, P equals gamma times m times v. Gamma is defined as 1 divided by the square root of 1 minus v squared over c squared. As v approaches c, gamma goes to infinity. The result? Infinite momentum, infinite energy. The relativistic conclusion is that it takes infinite energy to reach the speed of light. But remember, this isn't a physical barrier. It's a result of the mathematical definition of gamma. Meanwhile, the famous E equals mc squared isn't an independent law. It's a consequence of Lorentz invariance and the redefinition of energy, where c is a fundamental constant of spacetime. Andy Weir obeys this dogma religiously. But if we dig deeper, Einstein himself was conflicted about what space actually is. In 1905, he discarded the ether for the constant c. But by 1920, during his Leiden lecture, he took it back. He claimed gravity couldn't work without a medium. He just rebranded ether as space-time geometry. He took the physical properties of a medium, but refused to call it a substance. If space equals 0, propagation at speed c is impossible. If c exists, space cannot be 0. In the case of the Hail Mary, if space is truly empty, 0, there is no reason to limit speed. Next, geometry without matter, the EFE paradox. Einstein's field equations in a pure vacuum look like this: g mu nu plus lambda lowercase. G mu nu equals 0, because t mu nu is 0. It's Einstein's absurd logic that even when the content is 0, the container, the metric, can still curve. But curvature without substance is physically impossible. Curvature is a mechanical response of matter, not a property of nothingness. I'm losing my mind here. Okay, let's keep going.
Einstein had this cosmological term. He said, "It was my biggest blunder. I want to throw it out, get rid of it." But the problem is you can't get rid of it so easily. Because using the miracle of modern mathematics, you can rewrite that equation. And now this is a small step for a mathematician, but a giant leap for a physicist. Not because it's that hard to put this term over there. Most of us could do that. But because it now represents something very different when it's on this side of the equations. Here it was somehow a geometric quantity. When it's here, it looks like a new contribution of the energy and momentum of the universe. What could contribute a term like this? And we know the answer. Nothing.
Technical proof, the impedance of space, or Z0. In fact, physics acknowledges that a vacuum has an intrinsic impedance. Z0 equals the square root of mu0 over epsilon 0, which is approximately 377 ohms. In electrical engineering, impedance only exists if there is a medium. That value, 377 ohms, is empirical proof that space is a material, not an absolute void. Therefore, the speed of light is a terminal velocity, not a geometric limit. The formula is c equals 1 over the square root of mu0 times epsilon 0. C is determined by permeability and permittivity. Both are material properties. Setting a limit for c without acknowledging the medium is like acknowledging the speed of sound, but denying the existence of air. And then, inertia. If space were truly 0, mass would have no reason to resist acceleration. Inertia proves that matter is interacting with a real medium. The bottom line? Einstein gave physical properties to nothingness to make his math work, but banned the word medium, so the dogma of relativity wouldn't collapse under the laws of fluid mechanics.
That sounds ridiculous. Why should nothing weigh something? Nothing is nothing. The answer is nothing isn't nothing anymore in physics. Because of the laws of quantum mechanics and special relativity, on extremely small scales, nothing is really a boiling, bubbling brew of virtual particles that are popping in and out of existence in a time scale so short you can't see them.
Now let's run the test. If the vacuum is truly zero, and Lorentz symmetry isn't forced, then E doesn't have to follow mc squared. E equals m minus c squared is a result of Einstein's framework, not a limit imposed by the universe. Let's apply this to Grace's ship. Non-stop acceleration for 13.5 years in an absolute vacuum. No ontological speed limit. Classical mechanics. Constant acceleration at 1.5 Gs. Engines on the whole time. No coasting. Here are the parameters. G is 9.81 meters per second squared. Acceleration A is 1.5 G, which is 14.715 meters per second squared. 1 year is 3.15576 times 10 to the 7th seconds. Total time t is 4.26 times 10 to the 8th seconds. Final velocity in classical mechanics, v equals a times t. That's 14.715 times 4.26 times 10 to the 8th. The result, 6.27 times 10 to the 9th meters per second. In units of light speed, v over c is 6.27 times 10 to the 9th divided by 3.0 times 10 to the 8th. That's roughly 21. With 1.5 Gs of acceleration for 13.5 years in an absolute vacuum, the ship would reach 21 times the speed of light. And there is no mathematical violation here. This limit only exists if the constant c is forced upon us. Now let's convert that speed into distance. S equals 1/2 at squared, 0.5 times 14.715 times 4.26 times 10 to the 8th squared. That's about 1.33 times 10 to the 18th meters. Conversion, 1 light year is about 9.46 times 10 to the 15th meters. So, S is roughly 141 light years. This means in 13.5 years of non-stop acceleration, the ship would have covered a distance of 141 light years. From this, we know, if it weren't for Einstein's police, Grace's two friends might not have died in vain, and Earth could have been saved much, much sooner.
Grace, Rocky, save stars.